Good morning, students. I hope my voice is audible to all. Can I get quick response in the chat? Okay, thank you very much. Students, today we are going to discuss about the advanced verification topics in the system Verilog, which are mainly used for building test bench architecture and test bench components for verifying the designs. So the topics we are going to discuss today are, let me share my screen. Yeah, hope my screen is visible to all. Can anyone please respond in the chat? The screen is visible to all. Fine, thank you, Varsha. Today we are going to discuss about the topics like polymorphism, virtual classes, mailbox, and events. So why we are going for these topics? So in the previous class, we have discussed about the OOPS concepts, the class-based verification, the objects, and the instance of the objects, and the constraints. What are the importance of constraints and randomization we discussed. So this is actually extended topic of that. So here we are going to learn the advanced topics. Let me continue the session. Today's agenda, we are going to discuss about OOPS concepts and along with polymorphism, virtual classes and virtual methods, mailboxes, events, and verification architecture in the system Verilog. So why we are actually going for advanced OOPS? It actually helps to build scalable verification environment. So as we discussed previously, whatever the test bench we created, that should be reusable. So whatever the test bench we created, that should be reused to verify almost every RTL what it is provided by your manager. So like that we have to return the test bench which is reusable. For this purpose we are using this type of methodologies and all, and it is actually encourages reusable components, and as I said before, it is the foundation of UVM architecture, supports abstraction and flexibility. Flexibility, it can be used to any other design also. Coming to OOPS recap, so as I said before, class is actually blueprint, object is the instance of the class, and what are the methods and what are the variables you are retaining inside the class, they are encrypted and encapsulated in the class. So this is actually discussed before. So this is actually a relationship between the OOPS. So the class actually is a blueprint. The object, the instance of the class is called an object. So inheritance is nothing but whatever we want to extend the properties or methods, whatever if you want to add some more properties and methods, you have to extend the base class, and the extended class is called child have. That method can be called as inheritance, and the methods, it's your wish, tasks and function you can implement inside that. Coming to advanced OOPS concepts, wait a while. So these are all the things we are going to discuss today. Polymorphism, virtual methods, virtual classes, dynamic binding. So what is polymorphism? So polymorphism, actually polym is what you call many forms. It has many forms. Those the same interface with different implementation. Interface is nothing but your class. So the class can be implemented. So we can implement the class in different methods and we can achieve with virtual methods. So what are actually virtual methods? See, this is actually a base class with virtual methods. So polymorphism actually follows the some steps actually. Whatever the base class you are writing, you should mention a virtual keyword before the method which you are using here. So it's actually a void function, which is actually the name of display. And if you call display, it actually displays this base display automatically. You have to use virtual before that. So this is the first thing you have to keep a note while implementing virtual, while you are following polymorphism. And the second thing, this is actually child which is extended from the base class. So in this, it is no need to use virtual keyword before that. Only the base class should follow the virtual keyword before the method. And see, now in the runtime, we are creating the handles of base class and the child class. And here we are creating the object for the child. Automatically, the methods and variables inside the base class can be created object also if we create the child class object. Now here we are assigning base class handle to the child class handle. So now if you call b.display calls child method, not actually the base method. See, b is the handle of what? It's actually a base. So base b. If you call b.display means you should call the base display. So it actually prints the base display, but it will print the child display. How? Here actually we are implementing a virtual keyword before the method, and we are implementing both methods, base method as well as child method with the same name. I'm using display only. Here also display only. So same method we have to same method name we have to use, and we have to assign the base class handle to the child class handle. And if you call a method, like whatever the method if you want to call using base class or child class, only the child class method will be printed. Now the base class handle is have the control of controlling the child class methods also. This actually polymorphism. It actually implemented in the test class. While you are implementing test cases in the projects, this method will be followed whenever we are writing test cases. We can, while verifying a design, we are like so many test cases. So at that time, we have to assign the base class handle to the child class handle. Then to the base class handle, we can be able to control all the test cases. So for that implementation, this is the basic snippet for understanding. Now see, the polymorphism benefits are, so it actually dynamic behavior selection. So how many child handles you have? It's your wish. But the base handle is the main thing which is able to control all the child class methods. We can access the child methods just by assigning. Now improves code flexibility and use heavily in verification frameworks. So this is actually up to polymorphism. Then what is the actual virtual classes? See, if you want to use any class as a framework, not if you don't want to create the object of that class, then we will go for virtual classes. So actually virtual classes are mainly given by the managers. Let's take the upper hierarchy of we are working as a test case writer. The upper hierarchy is your manager, let's take. They only provide the frameworks of the classes. The objects and the whatever the functionality if you want to implement inside the class, you can extend that class and you can implement your own functionality. But the framework they will provide. That framework can be is of type of virtual classes. So virtual classes actually nothing but see virtual classes cannot be instantiated. So they can't be instantiated first thing and use it to define abstract base class. So just they are like actually a framework, not you can't create the object for them. So derived class must implement methods. So the derived classes we can add our own methods. So this is actually the code of the virtual class. So only the thing is like we can add virtual before the class. That's it. So we can't create the object for this class directly because it's a virtual class, it's just actually a framework. That's it. We can't create. Only the thing is like when we want to create, when we can create, we can extend this class with our own extended class. Then we can create the object for our extended classes. And here actually virtual class we can use virtual functions or like that. Sometimes we use pure virtual functions also. Purpose of virtual classes. So defines common interface. So that common class can be used by every extended class. So that is actually common class. From that so many extended class can be derived and we can add our own functionalities in that. So that is fixed. The extended class can be our own, like we can implement our own logic. Ensures derived class implementation and promotes abstraction. See, virtual class hierarchy. Virtual base class will be there. Always it will be structured. So let's take it will be fixed. It will be provided our manager. So some basic functionalities, they may have some basic functionalities. Now we can extend the virtual class to our with the same with with our own name that can be called as child class. and several extended class can we do through the virtual classes. So now going to the mailbox concept. See why we are using mailbox. So let's take, we are actually working on threads. Threads are actually nothing but we are working on two classes. So one class want to communicate with another class. Like, so these are actually called as let's take one class can be called, both classes can be called as TB components. So if you want to communicate one thing, like if you want to send some data from one class to another class, so we have to necessary, there is a mediator, there is a, let's take, there is a connection between the two classes. For that we are going for the mailbox concept. It's actually connection, it's actually a pipeline between two classes. Okay, so first class, let's take the classes can be, so many names we can keep while verifying a design. Some class can be called as generator, another class can be called as driver. So there are so many classes in the TB components, driver, generator, and even we have scoreboards and all. So for that, each and every component can be a class only. Okay, but each class can have some specific functionality. So first thing is like for a basic thing. So if you want to send the data from one class to another class, we need a mediator or we need a connection between the two classes that can be implemented using mailbox. So mailbox provides communication between threads. Threads are nothing but your classes used in test bench components. Test bench components are nothing but, as I said before, drivers, monitors. These are all test bench components. We will study in the further sessions what of them. And sub safe data transfer. Data transferring purpose we will use mailbox. See, so this is actually generator. It's a class only with a generator name, and it's a mailbox between the driver and generator. So if you want, like now I want to send the data from generator to driver. Through how? Through mailbox I can send the data. See the basic code of mailbox. So everything will be in module only. Here module and end module. You have to write like that. Then I am creating a mailbox. So this is actually the construct name and handle I have to provide. You can use your own handle here and equal to new. Now I am creating the object for the mailbox. Now in the runtime, I am using two initial blocks which will run parallelly. You know, both initial blocks will be run parallelly. In one initial block, I am putting the data. So how we can put the data? So before that, we will go to methods. So these are the methods of the mailbox. So these are the methods. Put is used for putting the object, putting some data inside the mailbox. Get can be like we can get the data, we can fetch the data. Try put, try get are non-blocking. These two are blocking methods and these two are non-blocking methods. So just know the difference what actually between them. Let's see for your better understanding. So this is actually a driver. This is actually what are called generator driver. This is actually a mailbox. So mailbox can be your wish. The size can be decided and size can be fixed. It can be anything. So you can fix the you can fix the size. So I want to like I want to insert only 4 data. So I can fix it by while declaration itself. Let's take, this is actually what I call, this is actually a generator which is able to generate the transactions. This is actually a driver which is able to get the transaction from the driver, from the generator, and this is driver. First of all, generator have to generate something and it should randomize something and we should randomize some variable and that should be kept inside the mailbox. The mailbox now stores the data and driver will fetch the data from here again. How like that communication will be taken between the generator and the driver. So this is a class 1, this is a class 2, let's take. This is able to insert the data and it is able to fetch the data. Like that actually mailbox will work. Now if you go the code, so this is actually what is actually this first class or something. Here we are not using the class types, just we are understanding the mailbox. Likely in the module itself we can do that. So here actually what happening? So through the mailbox handle I am putting some 10 data and through another initial block I am getting by, so it can be defined, it can be locally defined, it will be user defined. So whatever, so putting can be like you can keep any data yours wish, but getting should be assigned like get has some return type. That's why we have to declare a data type and that data type should be passed. Now that the data is able to get the 10 and it will store inside data. Now if you display the data, automatically 10 will be displayed. That is the mailbox actually. Like that communication actually happening. So now going to for synchronization. So let's take you have so many threads. Threads are nothing but let's say classes. So C1 class is there, C2 class is there, C3 class is there. So I want to make that after completing of the C1 class, C3 should run. C3 after C2 should run. So for sync that is actually synchronization. So that is actually controlling the threads. After executing first class, then I have to go for like third class. Then I have to go for second class. So like that I have to synchronize between the multiple threads. Threads are nothing but classes. So for that I should follow the events actually. So events actually contains what? This is actually for triggering. This is actually a method for triggering. The symbol is for triggering and this is for waiting. So I have to trigger here and after triggering the event this should wait and after triggering the event it will be going to execute. Like that we have to sync. So we have to communicate between them. After executing this class should be another class should be executed. Like that I have to make them controllable. For that we are going for synchronization. For that we are going for events. See how the code will be. So here actually I am declaring an event with the name of done. So now I am in one initial block. After 10 delay, I am triggering the event. So this is for triggering. Triggering purpose I am using this symbol. I am triggering the event after 10. Now another like parallelly another initial block is working. See, it is actually working at the 0 nanosecond at the rate done. Here, what happening? After 10 delay, the event is going to trigger. But here, at the 0 nanoseconds itself, the done is waiting. But if you sync both the like if I display, let's take after 10 here, if I display anything, I am writing dollar display, some statement here. So after 10, after triggering the done event, this display will be executed. Till the time this is waiting, then only this display will happen. Actually, this display should go at 0 nanoseconds. But since we are using here waiting, it will actually happens after 10 delay only. Why 10 delay? This actually trigger after 10 delay. So there is a sync between two initial blocks. That's why we are using triggering of events. So then this display will execute at 10 after 10 nanoseconds after 10 delay whatever the time you use there. So that's the purpose of events. See, so process A is there and process B is there. We want to sync between them. We will use events between them and verification architecture. So generator. So we're going for architecture. So your SP based verification is actually an architecture based verification. Directly we can't assign the signals. Directly we can't assign the values to the file. Directly we can't instantiate and directly we can't assign the values. Everything here went with the proper architecture. See, we will introduce the architecture. We will further discuss the functionalities of the each components in the architecture. First of all, in the architecture, we mainly have a driver, a generator. Let's take a generator. Generator is actually what? It actually generates the transactions. Transactions are nothing but it will randomize some variables and it will keep inside the mailbox. Now the driver is there. Driver actually here. So what the driver will do? Driver will drive like it will get the data from the generator and it will send the data to the DUT. DUT is nothing but your RTL design. So yeah, actually, if this is fully test bench, here actually DUT will be there. Both will be in the same hierarchy. But inside TB, we have the TB components like generator, driver, and monitor will be there. M for monitor. So what actually monitor do? Monitor will actually fetch the data. Whatever the driver will driven, monitor will fetch the data and it will give to the scoreboard or reference model. Reference model is there. Scoreboard is there. Scoreboard is there. So what are the functionalities of each TB component? We will learn. So this is actually a test bench hierarchy. And TB and DUT will be integrated inside a module, inside the top module. Since inside the top module we have the test bench architecture and the DUT parallelly So inside TV again we have generator, driver, monitor, scoreboard, reference model. These and all will be there. So after like with the integration of all these components, we are going to verify the DUT. So simple design can be verified using linear test bench, as I said before. But what about the complex designs? So we have to follow this architecture. Then we have in the limited time, in the less time itself, we can easily verify the complex designs using this architecture. That's the SV architecture actually. So here everything for connecting every TV component we are using mailbox. So that's the importance of mailbox. See, here generally it is actually architecture before I said the generator, mailbox, driver, DUT. Generator will generate the transaction that will be given to the mailbox. From the mailbox, driver will get that one, and driver will take the transactions and drive to the DUT. So up to here, mailbox will be there. So for generator, driver connection, mailbox will be there. What if we want to connect driver and DUT? That will be connected through the interface. We learned before, right? Interface. Through the interface, we can drive the data from driver to the DUT. So then in that concept will be actually through using interface. Why interface only? So whatever the TV architecture we are following here, everything is dynamic. So in the runtime only the memory will be created for everything. But our DUT is static. It is actually static in nature. Whenever we declare the compilation time itself, memory will be allocated. So and our interface also or static only. So for that we have to make our static interface to convert to the dynamic. Then only connection will be established between driver and the DUT. So we have interface and the communication between the TV components will be taken care with the mailbox. But for communicating to the DUT through the driver, we have to use the interface. So real verification scenarios, transaction created as objects. So what are the transactions we are, like I said before, driver is going to generate the transactions. Everything will be created using the class based only. We will create the object for the class and we will send that into the mailbox. Mailbox stores and it will be fetched by the driver like that. So again, mailbox transfers transactions. Transactions are nothing but what? It can be like a data type, whatever type. It can be like a bit type. It can be like a class type. Everything a mailbox can store. Driver executes protocol operations. Driver what actually? It actually executes protocol operations. Protocol is nothing but it follows some rules. Through some rules only it will drive the data. So these are the main interview questions we are actually going to follow. So what is polymorphism, virtual classes, mailbox, event synchronization. You can note them. Students, this is actually exercise. These all exercises I will provide through the assignment. You can take care of that one. So now we will summarize the concept. So what actually we are doing here? So advanced loops improves verification design. That actually we can understand through these all concepts and all. And polymorphism enables flexible behavior. Yeah. Virtual classes define abstraction. Yes, of course. The mailbox transfers transactions. The mailbox we gone through. The actual works for transactions, sending them and receiving them. And events synchronize the processes. So synchronization we can understand, right? Synchronization is nothing but controlling the different threads. What actually, after which thread? Again, after what thread should come? That actually synchronization. That's it. So now this actually we will go to recap. So polymorphism enables dynamic method binding. Virtual classes define base architecture. So what are the classes we are using? So they will define the architecture. First of all, every class like driver or monitor or scoreboard, everything will be virtual class only. After that, we will extend the class and we will provide our own logic. Then again, mailbox support thread safe communication. So safe communication will be there in a mailbox. We can get that out. We can use FIFO also, right? FIFO also for communication only. FIFO also we can store the data and we can fetch the data. But why mailbox only? Because mailbox have some methods, blocking, non-blocking methods. And we can create the mailbox object dynamically. So that's why we are preferring the mailbox when compared with the FIFO. So and again, even coordinate parallel process. So they are actually parallel process can be coordinated. So that's the thing. So today's session and we'll recap We will go for some snippets for better understanding. See, firstly we will refer the polymorphism. Polymorphism, as I said before, base class is going to control the child class method. It can access the child class method. See, here I am using class base. I am using virtual keyword and I am using the method with the display, name display. Now I am using the child class which is extended from the base class. Now it's a child class which is extended from the base class. Here I am not using virtual method but here the method name is only the display. So both methods are with the same name. So if I call the base method, it will display inside base class. If I call the child method display, it will display the inside child class. Now see, in the module, I am creating the handles for the both base and child, and I am creating the object for the child class. Now the object is created for the child. Now see, here I am assigning the base class handle to the child class. Now, now the base class handle will point the child class. Through uh, now the base class is going to have the control on the child class methods. Now if we use b dot display, actually b dot display means this method should be executed inside base class. But we are making the base class handle to point the child class handle using this assignment. If I call b dot display means it will display this inside child class like that. We'll run this code. See, it's actually displaying inside child class. It's displaying the child class method. So the polymorphism we can implement, we can understand what we can understand. The base class is going to have the control on the child method. That's the thing we have to understand. See the virtual class again. Virtual concept is nothing but it's actually just so there is you can't create the object for this class directly since you use virtual keyword here. Now we can create the object for the extended classes. Now this is the extended class from the base class. Now we can create objects easily. It's a packet P. So this is the packet. Packet is nothing but our extended class. We are giving the handle of P. So we are creating the object, and your wish. You can assign the values and you can call the methods. It's your wish. But directly we can't create the object for virtual class. It will throw the error. Now coming to the mailbox. Mailbox, as I said before, we can if through threads are running parallelly, we can we can change the data, we can exchange the data between them. So here two threads are running parallelly. These are the two threads. This is initial begin one thread, another initial begin another thread. In the one thread, I want to send the data. So I'm using the mailbox. First of all, we have to declare the mailbox handle, and then followed with the new constructor. Now the mailbox object is created. Now I can able to send the data and I am able to fetch the data. See here mb.put25. So through the mailbox handle I am calling the method put and I am putting the data of 25 inside the mailbox. Now inside mailbox 25 is there. Parallelly this thread is actually asking. So mb.get of data. So into the data I am getting this 25. If I display the data here, automatically 25 will be displayed. That's it. We will run this code for understanding what actually happens. So it is able to data sent and actually after that receive data. See, one second, your mic is muted. Students, my voice is audible to right everyone? So Vasha is saying the mic is muted. So my voice is audible to right everyone? Fine. Varsha, just rejoin once again. See, what actually happens here? So both threads are running parallelly. The first thread is going to send the data and second thread is going to fetch the data. So see, data sent. So first thread said I sent the data. Second thread is saying I received the data. That also 25 is received. So we can say that mailbox perfectly working and it's communicating and it's improving and it's actually developing the communication between the two parallel threads. Like this we can understand the mailbox. We can actually work with the class base also. You just create two classes and create the mailbox actually between the two classes. Just work on class based verification also. Just work on how the two classes will communicate. That's the task actually provided to you. Just work between the communication between two classes. Now see, this is actually event synchronization. As I said before, this is actually the triggering event. So if we want to control the threads, let's see. So here I am controlling this displays actually. So after this display only, this display should execute. So that controlling I am implementing here. See how I am implementing. Before this display, I am triggering the event, having some delay. Without this delay, without this triggering and waiting event, this display will execute at 10 nanosecond and this display will execute at 0 nanosecond. But I am controlling here with the triggering event. After 10, this will be triggered. After triggering, this will be unlocked. Then this thread will be executed. Like that, we are actually synchronizing between the threads. This can be done using events. So that synchronization mechanism we should work very perfectly. See, after event triggered only, event received actually working here. See, like that. But both are actually happening at 10 only, 10 delay only. So that's the magic here. Like this, we have to understand the events. Just work on complex snippets. You can understand the events easily. So see, now we are actually working on, as I said before, generator is a class which is able to generate the transactions. Driver is a class which is able to send the data to the DUT. So this is actually what actually happens here. See, I'm actually creating a transaction. So till now here I'm in the mailbox. What I actually kept is 25. It's actually what int data type or bit data type. It's like that only. Now onwards I am able to keep the class data type objects in the mailbox. See how I am keeping the object in the mailbox. First of all, object in the mailbox means first of all I have to create an object, right? So this is actually a class which is able to randomize the data. So data is going to kept inside the mailbox, which I am using the rand keyword. So I am using the randomization topic also here. Just to go, uh, just revise. So I am actually randomizing the data through the generator and I'm keeping the data inside the mailbox and the driver is going to fetch the data. That actually functionality I'm implementing here. How I'm implementing? First of all, I'm writing the class with the class transaction name and I'm using rand keyword before data. In the module, I am creating the object for the mailbox. Now I'm here using two tasks actually. So it's the task. One task is actually generator name. So I am actually taking the handle of transaction. So the generator actually generated, as I said before, generator actually generate the transaction and it will be kept in the mailbox. So before keeping something inside the mailbox, I have to create the object first, right? So for that, I am taking the transaction handle. Then I am creating the object for the transaction. Then I am randomizing. Now, if data has some random data, let it can be like 7 or 20 or 30. Since it's an int data type, it has any some random value is allocated to the data. Now that data, it actually keeping. So mb dot put, I am keeping the object inside the mailbox using the put method. Now I am displaying. So generator send the data. So t dot display. So directly we can't able to see the data what is actually randomized. We have to use the handle of the generator So we have to use the handle of the transaction. Through that only we can able to display the data. See, I am using another task which is actually driving, which is actually fetching the data. So for that also we have to declare a local handle transaction t and mb.get of t. While getting, no need of creating object. While putting only we have to create the object and then we have to put. While getting, no need of creating object. Automatically this local t will point to the which is pointed to the object which is actually inside the mailbox. Now mailbox has some object. That object will be pointed with this t. So driver receive the data t dot data. We will see. So now in the runtime, I am parallelly executing generator and driver. So I am parallelly executing generator and driver. So parallel execution nothing but generator is just generating the transaction and driver is going to fetch the transaction. Parallelly is happening in the within the zero simulation time. Everything we are working in the TB architecture which is run in the parallelly only. So as I said before, 5 components, right? Generator, driver, mailboxes and all, scoreboard, reference model. These are all TB components. All will run in the parallelly only. Those all will run in parallelly. Like this, they are actually implemented. So generator, driver, they will run at parallelly. So we will see the output what actually happens. So generator is going to send the data. See, generator sends the data. So since it is equally into data type, so this is the randomized data. So this data is generated and it's kept in the mailbox. So now driver is actually fetching the data. Like that communication actually happening between these two tasks actually. Like that you can implement two classes. So work on classes actually. So like that you can understand the mailbox concepts and all. So that's the students today's class. So these are the main concepts of working on TB architecture. So just get perfect in all these concepts. Next class we are going to discuss about the functional coverage. So that can be like how it actually verifies the it actually verifies the functionality of your TV. So how much you actually perfectly generated. So while verifying a design, we have to know every value should be generated and that should be given to the DUT for verification. So let's take DUT is expecting int data type of A. So it can, now we have to provide 0 to 2 power 32 values. That many values should be given to the DUT and that should be actually monitored also. So we should monitor all the values are generated or not. So then only, right, we can say perfectly the design is verified or not. That's why we are actually going for the functional coverage concept, which is actually monitor the randomized data and we can see the reports actually. So that's it, guys, today's session. If you have any doubts, you can clear now itself. And thanks for joining today's session.